This is a three-phase transformer. It has a delta primary and a Y secondary and is rated for 2 kVA. Confused? Well, don't worry, I will explain all of that. A transformer basically just takes an AC voltage and converts it into another voltage. We can get 1, 2, or even 3 different voltages out of the secondary side, but there are no moving parts inside and there are no wires connecting from one side to the other. You've likely seen these big green boxes at the side of the road. Inside is a three-phase transformer. These supply power to commercial buildings because they have a lot of lighting and equipment inside. Your home has much less stuff, so you only get a single-phase transformer. This might be pole-mounted or pad-mounted. We can see there are 3 wires going to the home, but this is not a three-phase transformer. They typically connect to just a single phase and the neutral of the distribution grid. It then reduces this voltage to a much safer level. Inside, we basically have a primary coil which connects across the phase and the neutral. Then we have another completely separate coil called a secondary, and the 2 hot wires connect to the ends of this coil and the neutral connects to the center. These wires run into the property to your electrical panel. The primary side has a single phase AC supply. The secondary side is also a single phase between the 2 hot wires, giving us 240 volts. The current and voltage are flowing forwards and backwards between these two as it is alternating current. But if we connect from the neutral to one of the hot bus bars, we get 120 volts because we're using just half of the secondary coil. The other side is also providing 120 volts, and it uses the other half of the coil. If we plug an oscilloscope into the outlet, we would see a sine wave. This sine wave has a positive and negative half of the AC sine wave. If we connect to each bus bar and the neutral, we see one side is positive 120 volts, while the other side is negative 120 volts. The difference between these gives us 240 volts. So this is just a single phase that is split into 2. However, you'll often see banks of 2 or 3 transformers which do provide 3-phase power to commercial buildings. But where did the 3 phases even come from? Well, the power station generates 3-phase AC electricity. The generator basically just spins a magnet past a coil of wire. The magnetic field pushes and pulls the electrons in the coil forwards and backwards as the strongest part of the north and south pole passes through the coil. This creates the sine wave with a positive half and a negative half, and this is a single phase. The generator spins the magnet fast enough that the sine wave repeats 60 times per second, and that gives us 60 Hz frequency. But notice the output power is not constant with single phase. We could add another coil which adds another phase and helps to improve this. Or we can add a third coil giving us 3 phases, and we see a much better constant output power. Notice we have 3 phases but 6 wires. Also notice the current is always flowing forwards in one coil and backwards in another. So we can combine the coils and the current will share the wires, only using them when they need to. We could try sending this power directly to the property, but it's very far away. So the resistance of the wire means we will lose a lot of power just trying to get it there. However, if we increase the voltage, we can send the same amount of power with less current. So we lose almost nothing. The power station feeds into a step-up transformer. This increases the voltage to hundreds of thousands of volts, and this will keep the current low over the long distance. Then, when it reaches the city, it enters a substation, and the voltage is reduced in a step-down transformer. This continues on the sub-transmission lines, and it might feed some larger industrial or commercial sites with their own dedicated substations. But it otherwise continues to the distribution substation, where the voltage is again reduced and then distributed out along the streets to the properties. Homes will then connect to one of the phases, while commercial properties will connect to all 3 phases. Three-phase transformers come in many designs, but inside, we basically just have three single-phase transformers joined together. A transformer is simply two separate coils of wire placed around a steel core. When current flows through a wire, it produces an electromagnetic field around the wire. When the current changes direction, the magnetic field also changes direction. When we wrap the wire into a coil, the magnetic field joins together and forms a larger, stronger magnetic field. When AC current passes through the coil, the magnetic field will increase and decrease as well as change polarity as the current alternates direction. If we place another coil in close proximity, the magnetic field will interact with the electrons in the second coil, and the magnetic field induces a voltage into that coil. If the path is complete on the secondary side, then a current will also flow. However, a lot of the magnetic field is currently being wasted, so we use a steel core to concentrate and direct the magnetic field, making it stronger and more efficient. The magnetic field will move around the core. This will induce an eddy current within the core material. This wastes energy and it also generates heat, and we don't want that. So we use lots of thin laminated steel sheets to build the core. This helps keep the eddy currents as small as possible. So when we apply a voltage to the primary side, we get a voltage on the secondary output side, and the frequency will remain the same. If both coils have the same number of turns, then the output voltage and current is the same as the input voltage. If the secondary side has fewer turns than the primary, we get a lower output voltage but a higher current, and this is a step-down transformer. If the secondary side has more turns than the primary, then we get a higher output voltage but a lower current, and this is a step-up transformer. In each case, the power transferred is the same value. For example, if this step-down transformer was supplying 200 volts and 10 amps to the load, then we have 2000 volt amperes on the secondary side. The primary side would see 5 amps and 400 volts, which is also 2000 volt amperes or 2 kVA. So the power transferred is the same, but the voltage and current change.